This question, relationship analysis question, is all about your knowledge of the gas laws and gas properties. So, first part, at the same temperature and pressure, 1 liter of hydrogen gas and 1 liter of neon gas have the same mass. So, a few ways to look at this. One way to look at this is, even though it doesn't tell us that it's at STP, standard temperature and pressure, let's assume it was for a second, just for the sake of argument, right? Let's just assume both of these are at STP. One of the things to remember is that at STP, 1 mole of gas occupies occupies 22.4 liters of volume. So in this case, if we have equal numbers, equal volume, right, 1 liter and 1 liter, that means we have the same number of moles, right? So if I have 1 liter of hydrogen and 1 liter of neon, we have the same number of moles of neon and hydrogen, right? Because we can see that the only distinction here is the it's going to be in the masses. We'll talk about that in a second. Right, we've got 1 liter of this, 1 liter of this. That is basically equal number of moles of each. And since the molar mass of H2 is about 2, and the molar mass of neon is about 20, if there's the same number of moles here, there's no way that this liter of hydrogen and this liter of neon will be the same mass, right? Because this is 10 times heavier just by weight. So this is going to be false because there's no way that, I'll write it up here, write it in red. This is going to be false because there's no way that equal volumes here are going to have the same masses when you're talking about two different gases, right? They're going to have the same number of particles, the same number of moles, and we're going to see more about that in the second part, but they're not going to have the same number of the same mass. So that's false. Equal volumes of ideal gases at the same temperature and pressure contain the same number of moles. This is true. So there's a lot of ways you can think about this. First, there's just an idea of equal volumes, equal numbers. It's just a general rule when it comes down to gases. So all things being equal, temperature, pressure, all things being equal, if you have two gases that occupy the same volume, they have the same number of particles. In other words, the same moles, basically. Right? And that's what we saw here. You can justify this by remembering the ideal gas law, which is PV equals nRT. If I have two gases that occupy the same PV, right? So they have the same P, they've got the same V, they've got the same T, right? As I say here, same temperature, pressure, and volume are all equal. And R is a constant, so that's always the same. The only thing that's left here is N. So N is the number of moles. And in order for these equations to be equal, the moles would have to be equal as well, right? So this is just restating what we said here. Equal volumes, equal pressure, equal temperature, equal everything. The moles are also equal. However, the mass is not, because the molar masses differ between, say, hydrogen and neon. So in this case, we have false true. We don't have to test for CE because it's not true. So that's it for that one.